All right, so this is day 13 of coding every day until I get employed. So for today, I tackled this leetcode problem, leetcode 1004 max consecutive ones. And for this problem, I referenced this YouTube video right here because it helped me a lot, especially when it came to visualizing it. And then our code ended up being quite similar because once I visualized it, I came across the solution, and our solutions were basically similar because we used the same concept. So given a binary array nums and integer k, return the maximum num of consecutive ones in the array if you can flip at most k zeros. So with this, we know that we want to flip k zeros and just see again what's the maximum number of consecutive ones in the array. So in this case, we got 6. So because we got this one, and or you could have done these two zeros, flip them to ones, and then got 6 with these remaining ones. So when thinking about this problem, we want to think about the fact that this is a sliding window problem, and but we want to tackle it a little differently than some of the ones that we've done before. So in this case, what was important was to keep track of how many zeros you're coming across, because we know that if we end up coming across like more zeros than our k would allow, then we don't even want to consider that string. And we can kind of think of it like one way to think about it is like if we kind of track how many zeros we come across, it's the same thing as saying that we know at the most we can flip, like in this case, 2 zeros, and we're kind of just I think you could even do the code by de-incrementing it. So like you could start with like 2, and you can continuously like decrease it, but in this case this just works better. So we would have, I'm just gonna go through the code and then explain how it works with this. So we have a left pointer and we have a right pointer, which both start at 0. And we have num zeros equal to 0. And we have a max, W means max width is equal to 0. Then we say for right in range length nums, we say if the nums at right is equal to 0. So then we say our number of zeros is increased to 1. We say while nums 0 is greater than k, if nums at left is equal to 0, then nums to 0 is minus equal 1. Then we always would increment our left, and then we calculate our max width by taking our max width that we initialized to 0, and then our right minus left plus 1, which would give us the size of our window. So kind of explaining how this code works. So we end up taking a left pointer and a right pointer, and we end up starting them both right here at this index, right? And so what we do is, as we iterate, we just say that, hey, if what we come across is a 0, then we want to increase our number of zeros, because we know we have a set amount of zeros that we're allowed to flip. And so what we say is that, let's say that we get to a case like, for example, with this, right? This would continue to go until you would hit this case where we know we came across a 0. So we would have increased our number of zeros, we came across another 0, number of zeros would have equaled 2, and we would have came across another 0, so number of zeros would equal 3, which would satisfy this condition to start this loop while number of zeros is greater than k. So now that we're in a condition where we use more zeros than we're allowed to, we want to shrink the subarray because we know this isn't something we want to consider. So we want to shrink it until we can consider it. So we would then say, okay, if nums at left is equal to 0, then we know that num 0 is minus equal 1. And we're doing that because we're going to shrink the array by moving our left up. So it just continuously gets smaller until we reach a point where we come across a 0. And once we come across a 0, then we can subtract one of the zeros from our number of zeros. And then we would continuously at every time increase our left to 1. And then the last part of this explanation would be our max. So we know that the size of our window is just going to be right minus left plus 1, because for example, when we start at this first index, right, we know that our left is 0 and our right is 0. So if we subtract both of them, we get 0, and then if we add 1, we get our window size. And then from there, we just consider each valid window size, and then we just find the max of that.